Here we have a problem on logarithm. Okay, let's read the question. Find the number whose logarithm is 2.4678. Logarithm is found for some number and the result is received 2.4678. So we have to find the number for which logarithm is found. Okay, we can assume let x be the number for which logarithm is found. So let x be the required number. So for the number x, logarithm is found, that is log of x is equal to 2.4678, and we have to find the number, that is we have to find the value of x because x is the number. Okay, so to find the x, what I need to do is I have to remove this logarithm here. I just need only x. I need the value of x. So I am moving this logarithm to the right side. If I move logarithm to the right side, it will become anti-log. So we get anti-log of 2.4678. So now I have to use an anti-logarithm table to get anti-log of 2.4678. So once I get anti-logarithm of 2.4678, so that's the value of x. I mean that's the number for which logarithm is found. Okay, whenever I want to get value for a particular number in anti-logarithm table, have to consider only the digits after the decimal. I am not supposed to consider the digit that we have before the decimal. So for example, in this, for this number 2.4678, we need anti-logarithm. So to get anti-logarithm for this particular number 2.4678, we have to consider only the digits 4678 which we have after the decimal. We are not supposed to consider this digit 2 in anti-logarithm table. So what are we going to do with this digit 2? So this will be included in the calculation bit later. So in anti-logarithm table we will be using only the digits we have after the decimal. So in this case we are going to use the digits 4678 in anti-logarithm table. Okay, let's move to anti-logarithm table. Here we have anti-logarithm table. So we have to find the anti-logarithm for this number 4678. Okay, to find the anti-logarithm of 4678, what we need to do is we have to take we have to go to 46th row and 7th column, mean difference 8th column. Okay, first let me go to 46th row and 7th column. 46th row is here and 7th column is here. Okay, in 46th row 7th column we have the value 2931. Okay, now let's take the same 46th row and mean difference 8th column. So we get 5, the same 46th row, 8th column in mean difference we get 5. Now we have to add these two values, so we get 2936. So this is the value we get for 4678 in anti-logarithm table. So always we have to take decimal for the value which we get from the anti-logarithm table. So the decimal should be taken after the first digit. So whenever we get a value from anti-logarithm table, we have to take decimal point. So the decimal point should be taken right after the first digit. So the value we get 2936 should be taken as 2.936. Okay, let's go back to the previous page. For this value of 4678, we get 2.936. We get the value 2.936 from the anti-logarithm table. Okay, so whenever we get a value from anti-logarithm table, it has to be multiplied by 10. Not only for this result, for any result we get from anti-logarithm table to be multiplied by 10. And for this 10, always we have to take the digit before the decimal as exponent. That is, in our problem, we have the digit 2 before the decimal. This 2 should be taken as exponent of this 10. So these are the process always we have to do for the value which we get from anti-logarithm table. So once we get a value from anti-logarithm table, it has to be multiplied by 10. And for that 10, we have to take the digit before the decimal as exponent. And already we know the value of 10 square is 100. If I multiply a number by 100, the decimal has to be moved 2 digits to the right. then I get x is equal to 293.6. So this is the number for which logarithm is found, and the result is received 2.4678.